Hey, Jonathan.
Hello.
Oh, it's quite echoey.
Hello. Hello. Yay, you've got it.
That was better.
So welcome to the dining room.
Oh, very nice. Is anyone else joining you?
I hope so, because Ash is talking, right?
Is he in today?
Yes.
Okay.
I told them where we are.
And Amina should be joining as well. But how are you?
Don't say anything sensitive because we're on YouTube.
Oh, right. Okay. Sure.
I'm good. I was just going through my slides. I haven't practiced at all. Yay! I'm telling the truth, I haven't practiced at all.
At all?
No. Did you prepare the welcome slides? I didn't do that.
Yeah, I've got the slides. I'll share my screen.
We're going to pull afterwards and you miss it.
Oh, a shame. But yeah, it's probably better that I don't drink.
I'm actually a budget from Paul and everything.
Really?
Yeah.
Oh, what for the programmed in pencil?
For going to pub, yeah.
Oh. That's nice. Do we get it will we get it every event?
I don't know.
Who else are you expecting to join?
I don't know. I'm just going to post. We will be starting in the dining room in 6 minutes.
Oh.
If there's no sign of people in the next couple of minutes, I will run like the wind to where Asher is sat, because he's in this building. He's sat downstairs. Hello.
How are you?
Hello again. Hi, Menas, how are you?
Hello, hello. How's it going?
I think it's
Sorry, I'll zoom out.
Yeah, maybe we sit behind you.
It was because obviously everyone's speaking, I wanted to like be visible.
All right.
I'll go that way. We could just use this as the speaker's spot and we could swap afterwards.
yes. Let's do
So
that.
that we could be really zoomed in on the speaker.
Ooh, those chairs are cozy. Sorry.
Dining room.
Yeah. Ah. Good work here. It's calm too.
If you can book it.
Just so you know, it's being recorded already
Oh, sorry.
and technically live streamed on YouTube, but no one's watching it right now, so it's okay.
Okay.
See, look, you can see a video of me on YouTube. Just out here.
Sorry about that.
All right. I just thought I'd warn you before I wasn't telling you off, I was saying, I was warning you.
And before I say some obscenities.
And we have one person already on the call. That's not working.
My brain just failed there to work out how to join a Zoom call. I'm doing well. It's good for me. Yes.
What? No Zoom. It's a Zoom webinar.
Where's the link for that?
I did add you as a panelist, so you should have got an email.
Okay.
Jonathan, any chance you can zoom out the camera in the dining room?
Sure, I was using that for like when I was talking. The plan is that we'll zoom in on the speaker, so that
Okay.
so I can zoom out for now. I'm not going to change the angle though, because we ages to get the angle right.
Sure.
I'm going to, and then me and we'll swap seats afterwards.
Mm-hmm.
So that Asher can talk. Natalie was lost. Was online, but she disappeared.
Hello, I'm back.
Welcome back, Natalie.
I lost internet connection.
You have the slides. We can't go. We can't like start our meeting without you.
Oh yeah, let me share my screen.
That's what we tried to do last time and it crashed.
Like it's working.
Can you see it? Yay.
Jonathan, can you send me the meeting link?
I can. I accidentally closed Slack 1 second.
Guess we'll give people a few more minutes to join.
Cool. So if people haven't come to Program Pencils before, it's our monthly meetup. Well, it was bi-monthly, but we're moving into monthly meetup focused on product engineering. We record all our videos and put them on YouTube, where they normally get more views than we actually get people attending the event. But this is our first one being run from the office. So we want to run it from the office from now on. Because I'm in on Wednesdays, it's on Wednesday, so I have to be run from the office. So I can go. No joke aside, we're running from the office, but and we invite people, external people to visit, to join us because we like to share. We quite often get external speakers. It's very rare. It's actually the first time we've had 2 internal speakers. It's fun, even though we've been running for a year and a half, first time I've spoken. I've refused to speak so far, but they finally persuaded me. And it's about having a platform to give people the opportunity to share their engineering views. So I encourage you to all speak at some point. Shall we get started, Natalie?
Yeah, let's do it. All right. Well, you've kind of already done a good intro, but welcome to Programmed in Pencil, everyone. We're sponsored by RVU. And today your hosts are going to be me, Nas, and I. We're both software engineers at RVU. And yeah, first up, we're going to have Jonathan speaking about web performance. Jonathan is a lead engineer here at RVU. Yeah, take it away, Jonathan. Do you want me to share, stop sharing so you can share?
Sure. My slide deck closed.
And we'll also be doing a Q&A after Jonathan's talk. So feel free to post any questions in the chat. And yeah, we'll get to them afterwards.
Cool. So if this is going to work. There we go. So, welcome to my talk, Programmatic Performance. So, as Natalie said, I'm a lead engineer here at RVU, where I work on the Money UK team to build out our financial service products. We spend a lot of time focusing on performance, and it's something we try to build as part of our team culture as we live and breathe the performance of our site, because performance is so important to the user experience that we provide our users. So, to start with, what I wanted to say was many talks about web performance, they focus on how you improve the speed of your website, right? They jump to the straighter steps to make it faster, so make your images smaller, reduce your JavaScript. And they don't really teach you how to gather your own data on your own users so you can make informed decisions. So that's what we're going to do today. We're going to spend our time focusing primarily on this data, both capturing the data and analyzing it, so that we can start making our own decisions about how to improve the performance for our users. So ultimately, you're better equipped to solve your users' problems, while also having a business case to do so, because with data, we can say to our product owners, our SLT members, yeah, this is why we need to work on this. So let's start with by looking at the different kinds of data that you can gather about your website when it comes to performance. So in particular, let's focus on two kinds of data. The first type of data we will collect is synthetic data. So synthetic data, as the name suggests, is data captured in a lab-like setting, such as from a server running on AWS or on your local machine. So yeah, for web performance, we normally run this test from a server. It could be on your host yourself, or you could pay someone else to be running a web page test server. The second type of data we're going to be looking at is real user metrics. This is quite often referred to as RUM. Real user metrics are captured in the user's browsers and reported back, kind of like an analytics event, but with a specific around performance. And when we're looking at this real world data or our lab data, there are 5 key metrics we should all be looking at so that we can understand the speed of our site. So the first of which is the time to first byte. This is the time it takes for a browser to receive the first byte of content. So if your server is slow at processing and rendering that content, it's going to take a long time to start sending data back to your user. So you would have a high time to first byte. So we should measure that so we know if a part of the performance problem is our server. The next is the first input delay. This is the time it takes for a user first interacting with a page, the time when the browser first responds. A poor first input delay normally indicates a problem with JavaScript. First content for payment. This is time until the point the user sees something on the screen. So imagine you're sat loading a website on your phone, and it's currently just a blank white page. It's when you first start to see something, maybe it's the header, that's your FTP. Then we have largest content for paint. This is the time to when the page's main content is likely loaded. So when the user can actually start getting a benefit out of that page. And we have Ergonomic's layout shift. So this measure of how much the layout shifts unexpectedly. So imagine you've got a big hero image at the top of the page, which takes a while to load. That could cause your page to jump the content down if you haven't specified the height. So let's have a look at how we would collect synthetic data. So to collect synthetic, the reason we want to collect synthetic data is we want to have an environment which will give us repeatable results. We want our results to be repeatable because then as we improve the performance, we can see those gains. So usually this would be a server where you can have a controlled environment. You have a consistent connection speed, consistent amount of hardware, and you might even tear it down and recreate it every so often so that you don't have any built up logs or caching that's going to affect your test. So when I do synthetic tests, I quite often use a Docker image called Browserless, which is a Docker image that contains Chrome and provides a nice API for interacting with it. Along which we also use Lighthouse, so Chrome comes with Lighthouse, and this is exposed from Browserless. So let's have a look. So I have a Docker image of Browserless running in the background, and and it's got the host name Chrome, imaginatively, running on port 3000, and what I'm going to do is I'm going to do a performance test of jonathanfielding.com. So I'm going to click run, so it's going to take a while. So what this is doing behind the scenes is it sent a request to Chrome on my computer to do a Lighthouse test. And then what I'm doing, I'm waiting that result, and then at the end I am logging it. So as you can see, this is the JSON response we get back from Chrome. So it gives us the Lighthouse version that was used, some information around fetch time. And as we go through, you can see that there is a number of different audits that we ran. So there is best practice ones, such as is on HTTP, are they stuff around like service worker, progress web apps, like are they a service worker? But then there's these important metrics we just talked about, like first contentful paint, and we can see the score it's given us. That is done as a decimal, but you could turn that into more of a Lighthouse score by times that by 100. And then it gives you a numeric value in milliseconds. So it says that my site took 1,915 milliseconds to load. And also what it would display it as on the Lighthouse report, which is 1.9 seconds. That's embarrassingly large. However, what you'll see is actually the first contentful paint on my blog aligns with largest contentful paint, and it's completed at 1.9 seconds too. So for context, my blog is actually hosted on GitHub Pages, so if it's slow, it's GitHub being slow. So having got our Lighthouse test results, we now want to pull out our metrics. I'm going to start this running again. So this is again just going to run a Lighthouse test against my blog. But in this example, we're going to pull out and log the first contentful paint, large contentful paint, CLS, first input delay, and time to first byte. And just logging it to the console. So you can see, oh, it's a bit faster this time, probably because we haven't cached it. So as you can see, I got good CLS, first input delay was quite low, and so it's time to first byte. Cool. To handle the variance between tests that we just saw, so we saw that originally it was 1.9 and it went down to 1.7, we can actually run multiple tests. So in this example, what I've done is I'm using promise.all to run 3 Lighthouse tests against my blog. That's going to send 3 requests to the browse Docker image. Then I am going to, as part of the, I'm going to run Lighthouse, and then I'm going to results. I'm then going to create an average of the results. So you can see here, we've got the, we're using get number of get average to get the results, and then within get number average, it's just reducing and creating an average. So with the data in hand, we now want to record it so we can monitor performance over time, because we want to be able to regularly look at this. So for this, I'm going to use BigQuery, which is a data warehouse product from Google. So I'm going to start this running while I explain the code. So it's going to run a lighthouse test, but this time it's going to store the average in BigQuery. So you can see we're using the Google Cloud BigQuery library, and what we're going to do is we're going to create a new row with a timestamp of the current date and the different metrics that we restored. Then we're going to insert them into BigQuery and done. So that we can look at that later. So when we can now analyze that synthetic data. So we stored our data in BigQuery, we start to analyze it. Start with, let's get all the data from our tests. So when using BigQuery, we can just use SQL. And if we run this, you can see we're creating a query job and then getting query results. And these are all the tests that I've run. The query I've run is actually requesting all the tests I've previously run. So every time I give this talk, this grows. As you can see, there's multiple tests and some days. So we want to group these so we can see trends over time. So what we can do is we can use a slick query to get the trends. So we can truncate the dates so into a day, and then we can get the average of time to first byte, first contentful paint, and first input delay, and LCP and CLS here. And that starts to give us daily averages, which is really helpful for being able to see trends over time. Having grouped that, we want to obviously visualize it. So in this case, I'm actually using a command line tool called Irvi. Irvi allows you to visualize data. So what I'm going to do is I'm going to take the data, and then I'm going to loop over that data to create some bars, and then I'm going to reverse it. So now we have a really nice bar graph. As you see, I originally wrote this talk in 2020, so the find and replace removing the year isn't working. But you get the idea that we can now render a bar graph. These visualizations allow us to understand the performance of our site day to day. So if we make a change, we can see what the performance of that pack was and know if it had a negative impact. And this will allow us to see what changes we have made improve or negatively affect performance, as I just said. Synthetic data like this will allow us to see trends in website performance, but it will not tell us what our real users are experiencing. That's why we need to look at real user metrics, because our users are accessing a website from all over the world, from a variety of different devices that we can't test on. So, capturing real user metrics. So real user metrics are performance metrics captured in our users' browsers. The Chrome team have released a JavaScript library that makes this easy called Web Vitals. So what you can do is you can import this library, and it has a method called getFCP, and then by running that you can then it'll then return the FTP. You pass it a function and it then returns it to that function. So if you want to get started quickly though, we can use unpackage to actually deploy that, use a deployed version on the internet. So here we have the unpackaged versions of Web Vitals. I've also got a polyfill for first input delay. We're then able to very quickly use a Web Vitals get time to first byte. In this example, I can only show time to first byte because the codecs only controls an iframe, and iframes do not report some metrics like CLS and first input delay for security reasons. But in this example, I'm calling get time to first byte, and then logging it, and then I just have this little div that logs this. So as you can see, this is the data. It gives us time to first byte. It gives us the navigation entry, and the details about that we can then send to our logs. Once you figure out what data to capture from your users, you need to store it somewhere that you can query this data and analyze it. There are many tools that you can pipe this data into. You could pipe it into your Google Analytics tool and start analyzing your performance data there. You can use Google Tag Manager and then use that as a pipe it somewhere. The segments, which literally can act as a pipe to a data warehouse or meta router. So in today's example, I'm going to pipe the data into segment. This is because it enables to pipe the data directly into BigQuery for analysis later. So we send a segment event and it will then push it into BigQuery. So segment exposes this analytics.track event. That event we can just send values to. So we have an event.name and a value. So using the Web Vitals library, we can call it for each of the methods, the log method, and then we can use the event.name and event.value, create a tracking event. I actually have this live on this code live on my blog right now. And then what this we can then verify that this data is coming through in segment. So what I'm doing is for each metric, I'm sending a different track call, so that over time, if say user cancels a page loading before LCP happens, I can see that drop off. So analyzing the real user metrics. So we've collected the data and stored in BigQuery. So what we're going to do now is going to start using some code to analyze it. The first way I'm going to do this is analyze the data is look at the median FTCP for over the past 7 days. The reason we normally use medians in web performance is it rules out any outliers, and outliers can typically cause us to think there's a problem when there isn't one, especially if the user had a faulty device or it was running lots of other things at the same time. I said that. So okay, so again we're using the Google BigQuery library. This time I'm using timestamp truncate as date, and we're going to group by date limit to 7. Again, we're going to also use the prox quartiles method to calculate the median. So if we run this now, we'll now have our data. So we have all the different medians for different days of visiting our site. Apparently this 20th of February 2021, my website was really fast. So having queried our data, we can now start to plot this data on a graph to see how the median changes over time. So we're going to do the same as we did earlier. I'm using the Irvine library to create a graph on the command line. I'm going to actually remove this replace bit because as we saw earlier, it is not working because of my data's a bit out of date. But if we run this now, what this is doing, it's creating a bar graph so we can see the trends over time. Along with median, to understand what a bigger percentage of our users experience, we should start looking at percentiles. So percentiles are important because they allow us to understand the curve of our performance metric. As you can see in this image, while the median, which is in the middle, that only actually shows us the first 50% of our users. Whereas if we look at the 95th percentile, we can say, we'll say to ourselves, 95% of our users experience this. So 95% of our users experience a page load of under a second, for example. To do this with BigQuery, we can use the prox quartiles method, but this time we specified different offsets. So I've specified a 50% offset, 75, and 95% offset. And then if we run this, we will now get many more pieces of data. So we've got median, P5, and thing. So you can see my blog, I haven't really promoted it much recently, so over time, they're actually mostly the same because it's probably one user. We can then also visualize that data alongside our median graph and compare them. So we can run this now. And what this is going to do is it's going to render 3 graphs. So we're in 3 graphs, and we can see, okay, median is like this, but on this day, the 75th percentile was much worse than my median. So there's obviously a problem that that the median user is experiencing, and 95th percentile is really bad. So need to try and understand what's going on. If I had a huge number of users on my site, I would definitely be concerned of this ridiculously high 95th percentile. This was just a small sample of things you can do with data once you have it. And besides simply looking at the data in this way, you can also start to combine it with your other analytics data. This will enable you to say, if a user that had this performance, so the person that was at the 95th percentile didn't click out, whereas someone who was at the median did click out. So you can say, okay, you can start telling a story of how performance is impacting the conversion of your website. So, in summary, by collecting the data, you can start to analyze the impact our site speed has on our users, and we can start to do something about it. This helps us understand whether we have a performance problem in the first place, and where to focus our time when trying to fix it. In particular, it allows us to start having those conversations as a team about what we should be doing about performance. I want to say thank you and I'll hand back to Natalie.
Thanks, Jonathan. That was really interesting. I liked the software that you were using for your slides. What was that?
So I forked, there's an open source framework called Spectacle, which is a React way of making slide decks. So I used that, and then I wrote some custom slide types, which are plain code, which is just code, interactive code, which is the Node REPL with the code editor, and then browser slide, which is the one which allows you to do the iframe, the browser that runs code.
Yeah, really cool.
All open source though, so you can find it on my GitHub.
Nice. Yeah, I might check that out. Cool. So we'll kick off with a few questions from Minas and I. If anyone else has any questions, post them in the chat. So you mentioned both like synthetic data and like real user metrics data. Do you, I guess, think that one is more important or more valuable than the other? Does one give you something that the other doesn't? Or if a company had to prioritize only collecting one type, which would you recommend?
I think overall, real user data is more useful because it can help you tell that story of like how a user is experiencing performance. However, I think there is always a place for lab data to try to have a consistent environment, because you might get a lot of noise in your real user metrics caused by different users. So it might be that you have more people in slow Android phones on a Friday than you have on a Monday. No, but like it could be like the way your audience shift changes from day to day might be different. So that could impact your data and make it noisy. However, if you have a huge amount of a huge amount of users, you should be able to remove that noise. But if you've got, so for quieter websites, you definitely need to rely more on lab data.
Yeah, no, that does make sense.
And lab data can also be done in different ways. So the way I use was browserless. However, there are tools like Web Page Test, which can run, you can run your own instance of in AWS, and you can even connect Web Page Test to real devices and actually see what's the performance is like on real devices as well. So there's lots of ways you can do the lab data to get different things out of it.
Yeah, that's really cool. And yeah, and I guess like you say, more useful if you've got a slightly quieter website. So then you mentioned quite a few metrics, different metrics. Are there any that you prioritize when you're sort of looking at web performance?
So right now, Google has putting a big emphasis on LCP, first input, LCP, which is like large contentful paint, first input delay, and CLS. So I think there's a lot of focus on those right now. However, I don't think you can discount the other two because they have a direct impact on those. So like your largest contentful paint is always going to be slow if your time to first byte is long, right? So
Yeah.
I don't think you can ignore them, but if you have to put an emphasis when you're talking about it, I would put the emphasis on those three.
Okay. And what kind of scores should we be aiming for? Like, is it possible to get a perfect score?
So the performance is subjective, right? Like some people might say, well, website's fast or slow depending on the type of devices they're using. But what people like Amazon found though, right, was there was a direct relationship between revenue and performance, and in their experiments they did see like I think it was 200 millisecond delay resulted in like 1% less revenue, which for Amazon is huge, right? That's billions, right? So like that 200 milliseconds was really important to them. So I don't think there's like a set number, but like faster is the best user experience, and it will impact revenue in most circumstances. Does that answer the question?
Yeah, no, it does. I guess it is quite subjective, isn't it? And you sort of have to, yeah, like use examples to benchmark against. So, yeah.
There is the rule of 20% that basically like users can only really perceive differences in 20%. So if you want to be better than your competitor, be 20% better than the competitor.
Yeah.
So that's a rule you can follow to help you know how fast to be.
Yeah. So is web performance more important for some apps over others, like SaaS apps?
So I've worked at a variety of different businesses, and every one of them has definitely had, well, I don't know, everyone, the past few have had performance issues, right? And that was a mixture of user-facing websites and SaaS apps, right? And both performance can impact the user experience and people's willingness to engage with the product. So in one of my previous places, we had a major performance problem on the page that you use to navigate GitHub repositories and add them for access, add them to give them access. And the more GitHub repositories people had, the slower that page got because it tried to load all of them at once. So we did a performance project around like rewriting the page so that we lazy loaded that content and only showed the GitHub repositories that the first 20, and then we showed the next 20, right? And that greatly improved performance and user experience. And in that example, it was unusable before because and it would stop that business from closing contracts with certain customers, right? So like, it's important for both.
Yeah. Cool, thanks. Does anyone in the room have any questions for Jonathan? No? All right, if not, I have one last one. Can you sort of talk about any specific examples of any optimizations that tracking and analyzing this data allowed you to do, whether it be on like your personal website or work website?
I guess there's a recent embarrassing one for myself. So we have, as all businesses do, we have a cookie bar, right? and doing some analysis of our page, I noticed that like our cookie bar was causing the LCP to be really long, and we obviously didn't really know why. So it turned out that when I implemented the latest version of our cookie bar on our website, I added a window on load event to around the cookie bar, because it was written in vanilla JavaScript. So I was like, I was writing this on load event, and that was resulting in the page waiting for everything else to happen before rendering the cookie bar, which then took over the entire screen. So that basically made the entire LCP happen at the end. So just reading those 2 lines of code greatly improved our LCP because we didn't have to wait that long. So through looking at the data, we were able to identify that problem and then fix it.
Really cool. I love that it was just like 2 lines of code as well.
Yes, also embarrassing. I was very embarrassed. I should have known that.
Nice. Well, thanks so much again, Jonathan. Really interesting talk. And I will hand over to Minas now to introduce our next speaker.
Thanks, Natalie, and thanks, Jonathan, for your talk. It was actually very interesting. I learned a lot. Next in line, we have Asher. He's a senior software engineer in RVU, and he'll be giving us the next talk. I'll give him a minute or 2 to set up.
I'll just move the camera.
Okay. Hi. Let me just share my screen and we can begin. So, my talk is about increasing your site traffic with page caching. So this is based on a recent piece of work that I did here at RVU, where we were trying to improve our page metrics. Thankfully, Jonathan's already talked extensively about that, so I don't have to go into too much, but let's begin and I will ad-lib as we go. So, first starting, I want to talk about Google Search because the business that we work at, Google Search is a huge part of how we drive traffic to our business. So, as you can see from my screenshots, it looks really nice because I cut it together, but multiple screenshots. If you do a search on Google, you get 2 different sections on the page. So you get the PPC traffic, which is showing you got this ad thing here in tiny letters, but that's significantly different to the one at the bottom, which in this case is a log, because there were a lot of different PPC traffic. So how that is shown to you and how that is decided is very different. So the PPC traffic, the ads, people generally bid to say, I want these keywords, please show me at the top of the page with these keywords. Whereas organic search is mainly based on how relevant the search engine has ranked your content towards that term. So basically, if you have a lot of keywords, if your page is seen as informative, you'll get ranked higher in that organic search. And that organic search is free, so it's a very, there is a very good business case to have your site at the top and optimized for search. But we can't discount the benefit of PPC traffic. So yeah. So that organic search has recently changed in a very significant way. It was called the page experience update for people who are in the SEO circles. But what that meant was that as a tie-breaking metric, 3 key values, as Jonathan mentioned, were prioritized. So if your site wasn't doing as well in those 3 key metrics as a competitor that you were equal with on organic search, you would be downranked comparatively. So those 3 key metrics are largest contentful paint, first input delay, and cumulative layout shift. I'm going to actually go over the definitions again, just for everyone to be clear. So the largest contentful paint is the time it takes for the biggest element on the page to be shown to users. So in most cases, that is a picture. But if you have a large amount of text and no pictures, it could be just a paragraph of text. And the first input delay is it's how long it takes. If you click a page, how long it takes for that input to be registered. So on pages with large JavaScript running, you can click a page and it won't actually happen for a while because it's doing the JavaScript first. So, sorry, preview there. And the cumulative layout shift is, as Jonathan also said, if your page moves about and, if you click on something, this is a problem. Cumulative layout shift is a problem because if you click on something and then it turns out that something is loaded in that place and you click on something else, that's very irritating. As a user of the website, I can tell you that's very irritating when that happens. So it's good that Google is prioritizing these things, but it meant for a lot of the businesses that we work on, we got downranked very significantly. Well, significantly, we moved from P1, the first place, to P2, and that has a very significant traffic decrease. So yeah, so the metrics we were trying to improve with this change was largest contentful paint. So when a website requests a user, yeah, I like that too. When a user requests goes to a website, enters the URL, it generally goes to the server, and the server we were working with, we found it was taking about 2 seconds to generate those pages, which if I go backwards a little bit, for a target of 2.5 seconds, an average of 2 seconds that doesn't leave any time to do anything else on the page. So that 2 seconds excludes the downloading of the image, it excludes everything. So that's not great. So if we were to meet the target of having 75% of users have largest contentful paint of less than 2.5 seconds, that excludes so many people, users with slow devices particularly. So what do we do about that is the huge question. So we did caching, which is basically where you have that data already prepared instead of going to the server and you just give it to the users. Our caching is done on our reverse proxy, which for a non-technical person, if you go to Uswitch, for example, Uswitch is made up of tons of apps. I don't know how many apps because I'm kind of new here, but you go to Uswitch and this is made of tons of apps, and those tons of apps have tons of different addresses. But as a customer, you don't need to know that because our reverse proxy just says you're going to Uswitch and it will point you to where you need to go. So it's really great for that, but we can also cache at that level. So we can say, oh, don't go to the actual server. Here's a cache. Take it from the cache. So it's a really caching at this level and this area is very beneficial. So let's go to the next page. But caching is also problematic at times because you can end up serving users of your site old content or content that is non-compliant. It can be a real problem. So what you do is you generally set the longest amount of time you want that cache to be available for. So that's called the time to live, because you don't want stale content. Really like that picture. So if your content changes, you can know, for example, if you set the time to live to be only an hour, within that hour time frame, you change that content, your users will get that content within the hour. Next page. So how do people get that cached resource? Generally, you want an exact copy of that data. You don't want to give someone a piece of data that's not what they requested. So you can identify the resources and say, oh, this person's asked for the exact same resource as what we got in the cache by looking at the URL. But you can also specifically on your server say, actually our page also varies by certain other things, and you do that with this response header called the vary header. We do that for some things where we work. So we thought caching, magic bullet, we'll get high LCP immediately, it'll be great. Didn't exactly work like that. We turned on caching, we saw the cache hit ratio is 40%, and we're like, okay, it might just be that the cache isn't long enough, so we're not caching all the people that we can be. So we increased the max cache age, the time to live, and the cache hit ratio was still 40%. So we had to go completely back to the drawing board. So what we had to do was work out how we identify the resource and how we say who is going to that resource. So, did that work? Cool. So, we looked at the URL, or the uniform resource locator in full. No one actually really says that before, generally, but I thought, let's put it down there. So, as you can see in the terrible colors I have put out there, there are different parts of the URL. So you've got the scheme, the domain name and the path. So the scheme and the domain name tell you, yeah, you're going to USwitch. And the path tells you what page you're going to. And those are all very defined things. In the time of HTML documents, it was, that path would take you to an exact document. That's why you have the .htm used to. So, but the query strings in the end, that is depending on the server. We use query strings to transfer information between pages, between the server and the user. It's completely, well, it's the Wild West is what I was avoiding saying, but it's my thing. So we can, with these query strings, pass information. So we can change the page based on the query strings, and that is why caching by default, every different query string given will give you a different cache, because that is the safest behavior to make sure that we don't have people getting given the wrong content. But obviously this is not the same for everyone. Specifically, Google search again, this is coming back. When you do PPC traffic, to pass that information from, say, Google, you're saying you've gone to PPC traffic, what it does is it adds this Gclid query string, which it's unique because it identifies you uniquely. But what that also means is that when you are going to the cache, no one has that same unique identifier. So that content is going to be, even though it is the same, you're going to get, you're going to have to go to the server and get that really slow time, that 2 seconds extra. But even though those, well, they should be the same page, but I was a little bit lazy with this screenshot. Even though those would be the same page, you might have very different speeds that you get the content from. So that's a problem. So all of these URLs take you to the same content, but as you can see, if you don't normalize the cache or reduce the query strings to the ones that are usable, they will take you to different things that will be terrible. So what do we do? The query strings can be whatever you want. The piece of work that I did specifically was to remove all the query strings that we knew didn't affect the page content. So that was a really big piece of work. A lot of tears involved, mine. But it really was very successful. What we found was that we could get, we had cache hit ratios about 80% almost immediately. It was very successful. When taken across certain pages, we knew within half a day that this was a very successful change. And our LCP on those pages dramatically increased because with an 80% cache hit ratio, more than 75% of the traffic was getting a good LCP. Specifically, this was on mobiles, which was good. So it was very successful, but and we increased the cache hits. But yeah, for a week, there was a lot of incidents because this is a nuclear chain. There are, yeah, you can, and I dealt with a lot of issues where you don't know specifically how your server works, and especially across USwitch, this change had to be implemented across the entire USwitch site. And as someone who at the time had 2 months tenure in USwitch, I had no idea about any of them. So it was a lot of firefighting because we had very successful. It was very successful, but obviously there were hiccups along the way, as Jonathan knows specifically. Multiple instances, but it was something that was very successful for us and something that I think was very central to us hitting our goals. So yeah, be careful, but you know, be very careful. Wow, said that. So is caching right for you? Ask your doctor or someone who actually knows what they're talking about. Is caching right for you? So basically, as I said before, the query string handling is specific to your server. So you will have to pay very close attention to what varies your page content. If you have query strings that change your page content, you should be making sure that those query strings are not being removed, or as we call it, sanitized, so that they can be passed to the server and give you the right content, and also your cache will respond to them correctly. But there's also a scenario where if you had a unique ID in your query strings and that was having to be handled by your server, then you won't see any benefit because you wouldn't be able to remove that. But you would also have to trying to cache against that would be almost impossible because your cache would be unique for every single customer with a unique identifier. And as I said before, with the instance thing, if you have a large site with lots of different apps running, you have a lot of organization to work out what is available, what isn't, or what can be changed, what can't be changed. And it's a big organization piece to keep all those things running with minimal instance. So that's it. And open the floor for questions. Yeah.
Thanks, Asher. We have a few questions accumulated, but let's open it to the room first. Does anyone have any questions in the room?
Well, should I just ask?
Yeah, go for it.
What tools did you use to implement the caching?
So our reverse proxy, as I mentioned, was Fastly. So Fastly uses this varnish cache layer language, which is the main way that I did this because it allowed you to rewrite the response and the request as it came in. So it was a very new language, but it gave me all the tools that I needed to do to get that in. So yeah.
How did you find working with the Fastly VCL?
It depends on the day. It was about a month, and initially I was super excited. Midway through, I was a little bit like, I don't know what I'm doing all the time, but I think it was very successful, and on the whole, I quite enjoyed it. But yeah, it was a big change, and it wasn't to be taken lightly. So cool. Any other questions?
We do have some, but is any other questions on the floor before I go mayhem on my questions?
Looks like a no from here.
Cool. The previous question lines up perfectly with my question is, can you achieve effective caching without using services like Fastly or Cloudflare or anything other?
So services like Cloudflare and Fastly are content delivery networks. So you probably could, but I wouldn't recommend it because the content delivery networks, the main thing they do is locate your resources close to your customers. So if you weren't using a content delivery network, you would incur the cost of having to get your resources to your customers. So possibly, but I don't see a situation where you would do that, if that makes sense.
Cool, thanks. Are there any other methods that you explore to improve LCP or other metrics?
So before this, one thing I noticed about this site was it was pretty much doing, Lighthouse tells you, oh, you got this wrong, go fix it, the easy fixes. And what I found was that we didn't have that many of those when I was running the Lighthouse tests. Initially, we did a small fix because we found that we were lazy loading all the LCP images. So what that meant was that it had to download all the JavaScript for all the page, run it, and then it would load the images. So that would make the LCP element the last thing to come in. So that was a really quick fix that was able to do and get out, and it did have a bigger effect, but it didn't get us over the 75% target we're going for. So I would say that what you have to do is kind of specific if you're doing all the fundamentals correctly, but Lighthouse gives you all the tools you need to know to if you're not. So yeah.
Thanks for that. Next question is, did you explore just making your servers faster?
We didn't. That was definitely a possibility, and we definitely realized that if this wasn't going to be successful, that was something we're going to have to do. What our servers do is actually quite complex compared to all the other places I've worked before. So while that may be something we have to explore in the future, and it probably will be, I imagined it would have been a lot bigger of a piece in the time frame that we were trying to get this across. So.
Excellent, thanks. Jonathan is asking, could you have removed query strings completely?
No. All the apps that I encountered used at least one query string that we needed, one query string to change the page content. The one that I worked on specifically, we have guide pages where you have multiple pages of those guides, and how you see the pages is the page. You have a page query string that says you're on page 1 or page 2. So that isn't something you could do if your server isn't set up that way. But I guess if you end up making pages with no query string, that don't use query string, you can just cut rid of them, cut them out completely.
You mentioned one of your last slides is how do you identify if caching is right for you? What was the process that you went through in order to identify if it's the right thing for USwitch or RVU in general?
So for USwitch and RVU, it was an app by app basis. The app that I was working on had caching enabled already. It was thought to be something because, but there were a lot of apps that it probably won't be immediately beneficial for, because they are, how do I say this? They are more unique. So a lot of our tables are dependent on the user because they pass through an immediate, an identifying number to the link. All the buttons have the identifying numbers to pass them through to the, sorry, losing the word, the suppliers of the deals that we give. So those pages, caching, you can't really cache a page that's unique to a person. So that's the big thing about how unique your page is. So highly personalized pages are, you can't cache them. Otherwise you give someone a personalized page for someone else.
Cool. Back to the CDNs, Jonathan is asking again, do other CDNs have similar issues with caching and query strings?
I didn't look this up specifically, but I think so, because you can't exactly, you need to base the cache on the URL. You can't just say no query strings unless you know for sure that there are no query strings used. So I think a lot of the CDNs take the safer route and say all the URL.
Cool. One question from Natalie goes, do you know the impact of caching on all the metrics, aka revenue, etc.? Or is that?
No, I don't. I could probably find out given some time. I know that a specific metric for the mobile page that I mentioned in the talk was when we dropped from P1 to P2 in the search terms, it was estimated that because of the loss of traffic to the site, that USwitch would have lost £2 million because of that change. So that is a number. Yeah.
Thank you for that. Now we have some silly questions from myself. How many sleepless nights did you have during the projects, and would you do it again?
Sleepless nights. I actually sleep quite well, even if I'm panicking. And no, I think that's something I have developed after like freaking out continuously all day. I do need that sleep. Would I do it again? Yes. If you had asked me in like mid-February, I would have said absolutely not. Please take this away from me now, anyone. But yeah, in retrospect, now that I'm not currently doing it, yes, 100%.
I think gonna need a follow-up talk from you on how to deal with what you've dealt. Jonathan is asking, did they buy you cake after it was live?
Sorry, can you say that again?
Did they buy you cake after the project was live?
Should have.
Yeah, they should have, you know, you said, yeah.
Should ask for that. And I might be talking on behalf of everyone, but we love the memes. Thank you so much.
Thank you. That was probably me doing it too late at night, so I'm glad everyone enjoyed it.
If there are no more questions, I think we can leave it here and the meetup for today. Cool. Take that as a no. So once again, thank you to all our speakers, Jonathan and Asher. We'll ping you again once we need more of your lovely talks. And thank you to our sponsor, RVE. And with that, please keep in mind that this is a monthly meetup, so keep your eyes and ears peeled for the next one, which should be towards the end of May. And thank you for coming.
Thank you, everyone.
Thank you.
Thanks.
Bye.